Like, how to imagine that?
I can describe it as one big button where you can press punch in. It's doing nothing.
Let's dive into architecture. Let's dive into your system.
There are many metrics, more than 30 or even 40 metrics.
That sounds like quite an interesting problem to solve, I need to say. Hello and welcome to the new episode of the Architecture Deep Dive podcast from FW Days. Today we have a very special topic and great guest to discuss that topic. So we'll be talking about traveling space and time with a solution called Temporal. Today's guest is Andriy, who is a tech lead at Day.io, where he leads infrastructure team. And with his nearly a decade of experience in production development, I think he'll be a great guest to talk about that topic. Much of his experience is connected to working on real-time systems under unpredictable and spiky loads. So Andriy brings deep hands-on experience on scalable architecture design. In today's episode, we'll dive into how Temporal.io can help manage real-time reporting in systems with bursty and nonlinear traffic, from something like short-lived pipelines to long-running background workflows. I guess we'll try to cover it all. And first of all, I'd like to give a quick shout out to Andriy's talk at Highload FW Days conference on this very topic. So we'll put a link down in the description below. You can check it out, and it's definitely worth watching it. Andriy, welcome to the podcast. Very happy that you joined today's episode. And in the beginning, I just wanted to set some context, to discuss, like, first of all, what is the AIO? What are you doing there? And please give us any details or any hints about that.
Yeah, first of all, thank you for invitation. Very glad to be here and talk to you, Oleksii. Okay, so DAIO, it's a company which is working on South American market, especially in Brazil, because it's the biggest market in Latin America. And we are providing services for government's reporting, because they have a kind of special law. So every time you pay salary to your employees, you need to provide reports based on what the salary was calculated. Like you cannot just say we want to pay $1,000 to this guy and that's it. You need to provide information how many minutes he worked, he was on break, he was absent because of vacations or medical leaves, and so on. This is like very high level explanation. There are many metrics, more than 30 or even 40 metrics that we are calculating and providing to our customers. And we are collecting these events from devices where we have our own applications. It's mobile devices, tablets, also web widget. It's not kind of like screen recording. It's I can describe it as one big button where you can press punch in or punch out. It means that you started your working or you finished your work day or went for a break. And we are gathering these events. Then we are calculating all the metrics, comparing these actual events with expected events from configured schedules for employees. And we are calculating everything in scope of one working shift, then if needed in one working day, because there might be employees with multiple shifts per day. And then we are aggregating all this data for reported payroll periods. It can be 1 month, it can be more, it can be less, it depends, and it's configurable, which is not very good for us from technical perspective because it's not very predictable. I think.
That sounds.
Also, we have many integrations to receive these events from other sources, and the integrations to upload these reports anywhere it's needed.
That sounds like quite an interesting problem to solve, I need to say. So Yeah, I think you have described a lot that happens after you click that button, punch in. That system does like plenty of stuff to calculate everything and collect those reports and generate all stats. But like in your talk, I liked like you start from the legacy system. So I wanted to talk a little about that, like in terms of context, right? Where you started, like what was the system before you introduced a new solution, how it looked like, and what were the pain points in that system?
Yeah, we need to understand that DAO, it was established at 2017, something like that. So it's almost 10 years old company, and like every startup, guys tried to find their market fit and market value. So guys tried to produce some solutions to solve customer problems and find these customers. And as we know, it can lead to something which is not easy to scale in the future, especially when you understand that your current solution is not suitable for your problems and you need to change it significantly. So what we had in the past, like entire system, it's built on top of Node.js microservices, and also there is one on Ruby on Rails, like the one from what everything started back then. Like we tried to find a solution to have kind of data pipeline when we create these events, collect these events, and then calculate everything. And technologies were chosen respectively because guys didn't want to choose anything in-house because you need DevOps to set up everything. So they chose managed solutions like PubSub and other Google Cloud solutions. So it led to multiple technical problems because PubSub has its own retry mechanism, and if you are not sending acknowledgement message, it will start bombing you with duplicates. Also, Google PubSub doesn't have the duplication mechanism. So if suddenly you need to recalculate metrics for today for some employee, and accidentally he clicked multiple times, we cannot ignore these events because everything should be logged somewhere, and any of these events should be triggered for a calculation. But if there is a queue and we received new event, there were no way to skip outdated recalculation tasks. So that caused a problem, and we tried to solve it as a company. We tried to solve it with different with different custom solutions, like queues in Postgres, where you can remove some events from the queue and manage it in different dimensions. It led to increased latency and didn't solve the duplication problem completely because you still had PubSub events. And you couldn't run this deduplication on top of Postgres every second, every minute. So we still had this. And another problem was like there were a few microservices created. The one, it was to calculate daily metrics because we expected that it will be kind of CPU intensive job. And another one, it was aggregation microservice. And at the very beginning, everything was good, but like as time was passing by, new requirements appeared, and it led to new layer of business logic added to aggregation service. And for some reason, they started copying a lot of data from the first service with raw data, with raw calculated data, to the service with aggregations. And it caused kind of circular dependencies in events chains, That's what we had when we started working with this system. And another, it's product related issue. Anyway, we wanted to rebuild this system because like company was a few years, like 6 or 7 years old, and you had a big layer of business logic which was added during different periods, and a lot of requirements. It was like just naturally overloaded in existing logic, so we wanted just to rebuild and create a much better service structure.
Yeah, all of that makes sense. So first of all, I think that's the beauty of working with real-time data processing pipelines, event-driven systems. So part of it is just the system complexity, right? And second part is that you're as a company kind of collected that tech debt, and features were more important than technical solutions. And in a growth phase, it's totally fine to do what they did. So I don't see any issue there. But at some point you decided, hey, there is a cool thing there, like, right? There is a temporal. And I'd like to ask you about that a little bit. So first of all, for those who don't know, like, what the temporal is, and second question, like, why temporal? Could you walk us through, maybe you have some slides or something to show us, that'd be helpful.
First of all, I want to say that at the very beginning, we wanted just to rebuild the business logic, maybe with some custom solution. But when we started encapsulating all the pipeline stages, we understand that there are two ways. First, we will write a orchestrator for these stages by ourselves, or we'll try to find out for something else. That's how we started exploring tools. And during my previous experience in previous company, we started working with Cadence. It's actually Temporal, but with previous name. Then they did rebranding. And we knew about this, and also our CTO had positive experience with Temporal IO before. So that was the first choice for us. We were thinking about Airflow, but it seemed to be like kind of overkill for us. And with this DAG approach to create workflows, like for us, it seemed that it will be much more complicated, and we will take more time. It will take more time to do onboarding for new people, and all the examples we saw in temporal documentations, it seemed very good for our case. Also, we had a few calls with guys from Temporal, and like they said that it's like our use cases are good for this. By the way, their community is like very good. They answer questions very quickly. Like it doesn't matter which issue you have, they always try to help. So that's another big pros of why we chose Temporal. Like what is it? It's like a solution that helps us to orchestrate workflows. That's in short, there are two possible ways to use this. One is a cloud solution, when you delegate everything and just pay for usage, but it is very, very expensive if you have many workflows. That's our case. But if you want to offload from yourself all the logic, let's say sending letters during the month, scheduled letters. Yeah, usually you don't have a lot of letters, but this logic to support deployments, failover, and everything, you will not need to implement it. You can just call an API call, like send this letter in 30 days, and that's it. And second, it's an open source solution. We had two DevOps engineers, and it was a good task for them. And also, Temporal provides all the Helm charts that you need. So it's very easy to build this cluster. A cluster consists of core service, which is managed on all the queues, timers, and states. It provides both CLI and web UI tools, which is very useful as well, because I will show it on the next slide, maybe, because UI is like very, very good and verbose, and you can see everything. You can find there almost everything you need, and it's visualized very good. And the third, it's our own application. It consists of two parts. Basically, the first one, it's the part where you are creating workflows, and the second, it's workers. Good thing that workers and where you create workflow invocations can be on different servers, written in different languages, and so on. They provide SDK for almost 10 different languages. We chose Node.js because it's good for us. There were another different issues with Node.js, but maybe later we'll discuss it. So you create workflows from one place. It's doing nothing. It's just creating workflow, and then subscribed workers take these micro tasks from temporal cluster using long polling and execute these micro tasks.
Yeah, actually, you mentioned like workflows, and in the context kind of like work queue processing, when you have a queue of things you need to do, and workflows that execute that. Also, I saw that Temporal often used, like for things like coordinated sagas, when you have multiple things to do in microservices or service-oriented system, and you have one coordinator, so that'd be a temporal workflow. If you can name some of the workflows you use or you do in the AO, like what kind of things you could put into workflow? So like how to imagine that?
So this is how usually a workflow can look. It is one of our workflows. It's just a simple function, and this function, you pass this function when you call workflow creation via SDK, and inside you can put your own code to manage your activities. And activities are atomic parts of workflow, which temporal is managing. Yeah. So for example, you create this is workflow to send overtime alert. What does it mean? So when person starts its working day, we know how much time it should he or she should work. But when there is no event that this working day was finished, we need to send alert to supervisor that overtime period started, because companies are paying for overtime, and it's not very good usually. Good thing that Temporal provides a lot of tools to manage these long-running timers. So we are creating this timer, and even timer, it's a kind of built-in activity. So you just write await timer, and you don't care. This timer can be like for hours, for days, even for years. And Temporal is managing this. And then when it's time to move forward with your function, it's passing to the next line of your function. Mm-hmm. It may seem a little bit confusing at the very beginning, because you have like just a function, and this function is split into small chunks of execution, and they are executed maybe even during different days. But that's the beauty and the simplicity that Temporal gives us as a customer of this tool. So you shouldn't care. You shouldn't care about managing everything else. And these activities, it can be like whatever you need. So in this case, this activity is just sending alert. It's push notification. In other cases, it can be like a batch of some business logic that you need it to be kind of transactional, because as we can understand, this workflow written in such a way, it provides us transactions. That what is usually difficult to implement in distributed sagas on top of events. Yeah, because you need to manage rollbacks, and like quite often people just skip implementing rollbacks because it's not a situation when sometimes business is pushing like come on, you don't need this, it will work perfectly, but here rollback it's just try catch function.
Hey, and that's not easy to implement those compensation transactions. So this is like not an easy topic to do.
Yes.
Yeah, thanks for explaining the workflow structure. I think it's very, very important to understand that before you go into Temporal, why you need that. If you faced with that problem before, I think you exactly know that that's a very great solution, because like you'd have your state machine, like your transitions and your activities as actions within that state machine, and also you're storing the state of that, and also you're tracking your retries, and also you're doing your fallbacks. So that's very great thing to have. And for guys who working with sagas and implementing those, I bet you created some sort of coordinator that would look similar to this one. But you'll need to do a lot of things, like to track how that coordinator executes, which workflows were successful, executions were successful, how did they resolve. And you mentioned there is a UI like for Temporal. Could you give us a peek, like what it looks like and what it has? Why do you like it or don't like it?
Yeah, to observe everything and collect metrics, it's kind of different topic. But good thing that Temporal provides not only UI, they provides also Prometheus metrics setup and Grafana dashboards. You don't need. Of course, you can adjust it for your needs, but basic observability is there. And for debug purposes or just visualization for non-technical people, they have this UI. It's part of screenshot of single workflow. Yeah, how it looks like. We will not dip into details of like execution stages, but you can see that workflow was invoked here. And it's easy to see that these micro tasks, yeah, and they are listed here. So your execution pipeline is easily tracked, and you can see what failed, what was successfully finished. Also, retries information is also here, and as we mentioned before, both workflow and activity looks like a function. So here you can see your intermediate and final results. Yeah, you will see what was the input of this activity and what was the output. And if you are confident that your activity is well tested, it's working well, you can mock it for your tests, which is very useful as well.
And I think at this point, Temporal sales team can contact us and give us some percentages from sales, because the tool is great. What can I say? But in real world, in real context, it may be not so great. So I'd like to talk more about that. And first, let's dive into architecture. Let's dive into your system. Could you please explain us or describe like what is your system at high level? What is the setup?
So we have a bunch of microservices which are producing events that are affecting calculations of our metrics. It can be punches that we mentioned at the very beginning, like absences, schedules changes, everything. So if something, business rules changes, if something was changed, we need to make sure that our calculations are up to date. And the problem was that all these events, they were sent from different services in different formats. We tried to find a unified way, and we put a Kafka as a queue here, and collected all the events in Kafka and tried to put them in single format. Yeah, and this Kafka consumer, it was our point of workflow creations. We just received the event, validated that this event should be a trigger. Yeah, because sometimes from and to can be invalid. For example, yeah, or employee is not existing in the system if it's something from third-party integration. So this was a kind of validation level. And then we created workflow here. And we had separate deployment pods, which are workers. There were also two kind of workers, on demand workers and kind of regular, because if you are making changes from the UI, you expect to see these changes reflected immediately. So we had high priority queues and regular queues.
So with this, like where the workflow starts, we talked about workflow activities. I guess there is a third concept called signal, right? So what's signaling a workflow start?
I would like to move to this one. This was our initial setup. Consumers, then we have workflows creations here on consumers. Workflows are sent to temporal cluster, and then workers subscribe to temporal cluster, moving forward with executing these micro tasks and activities. So that was our initial setup. I'm putting away everything additional, which doesn't make sense right now. So the first version was of workflow. It was like we tried to do it like we understood after reading documentation, talking to these guys. We want to encapsulate logic for each independent piece of business logic in separate activity, because you can configure that activity should be repeated until it's done. How much time you can configure try logic, and it will be repeated and executed one and only one time. It's guaranteed by Temporal, which is important for us. So we had very simple workflow. Workflow ID, which is kind of unique key inside of Temporal, and multiple activities. Here we didn't have any signal, anything, and when new event was coming, we just terminated existing workflows before persisting results and started from the very beginning. Of course, there were cases when we were terminating it too much times, but we knew our system is not creating a lot of similar events during long period of time, so we could do this. The problem was that Temporal is not working very good with like very short-living workflows. Because Temporal cluster should do a lot of internal work in this case. Because if your activity is for a few milliseconds, then it needs to manage this activity, create, run, close, move to another one, and too many operations per second. That's what we had.
Well, that looks like a great approach. I mean, in terms of workflow and solution, and to me, it sounds reasonable. To be quite frank, what I wanted to ask you is, we're talking about the workflow implementation, but do you have any numbers about the like beginning state, like what was the load on the system, how it looked like, so we can see the solutions, improvements, all that kind of stuff?
So here we can see that there were a lot of stages during workflow, and also we had many workflows. It was like more than 2 million events per day, and more than 30 metrics for each period. So we can just multiply and understand how many activities Temporal cluster should manage. And also there were some metrics which were dependent on the previous day, so complexity was even bigger. because we always need to recalculate period, and for some metrics it's from the start of the period till now.
Like you had your legacy, you've started to implement the workflows things, and what were the results? What did you achieve from the first try?
From the first try, it was good because we had the duplication logic much better than in previous implementation. Because in previous, I can show, if we had a glitch in the system or something on some of services was not operating normally, we almost immediately started having this snowball. And this is not unique events. These were duplicates, and our queue should be processed before system started operating normally. And here it was much better. And this graph, it shows us kind of rate logic, because blue it is terminated workflows, and green it's completed workflows. So we can see that like sometimes most of half of workflows were terminated. So it means our like duplication rate was more than 50%. The problem was that operating with huge amount of activities almost killed temporal cluster. Everything was at 100 CPU, both workers and the cluster, and the scaling didn't help. It was just too much. So we did the next. We tried to fine-tune configurations. Of course, there are a lot of options, but the next step was to reduce amount of workflows and amount of activities. So we merged activities into bigger, so it was easier for cluster to operate with this workflow. And also we started making this deduplication logic not via termination mechanism, but inside the workflow. It's very good tool that Temporal provides. Its signals. So in case you have running workflows, you can fire a signal, and Temporal will send this signal inside of your workflow runtime.
How is it different from termination of a workflow? Could you explain like how it worked before and now with signal? What was the change?
It's much easier. It's much easier operation for the cluster, first of all, because when you have workflow, Temporal is operating with workflow history. So there are lots of records, and it needs to start workflow from the very beginning every time. And there is some amount of history events which are kind of default for each workflow. That's one. And second, we noticed that termination plus new workflow invocation had quite big latency. Just because of this closing workflow history and creating new one. So this sending signal inside without any manipulation with workflow history was very helpful for us. And inside this workflow, you can do with signal whatever you want. We had kind of small in-memory queue in scope of only this workflow. As you can see in our workflow ID, which is kind of unique key, it's only employee ID. So we had all the events for a specific employee inside the single workflow. And in this case, we could choose the earliest if there are events ordered, or we can calculate intersections of periods, or if there are same periods, we can just ignore some. And we didn't interrupt everything. So we had this internal queue, and after some activities, we checked if there is an event in queue, and if we need to start from the very beginning. Let's say we had this prepare sources activity. We prepared all the sources. We checked, okay, we have another event. let's prepare sources one more time before we started actual calculations. It helped us a lot.
Yeah, makes sense. So what were the results of this? Did it help?
Here I have some metrics to show. This is CPU and memory usage of workers. So with some fine tunings and using workflows, we didn't use a lot of memory because every workflow Temporal tries to execute on the same worker. Because of the context and the history, workflow history. And especially if it is short-running workflow, it's very helpful. There is kind of timeout, how much time Temporal doesn't try to move workflow execution to different pod. And when we were killing this and recreating, we had to spend resources for this. You can see without frequent termination and recreation, it was much better. And also scaling worked much better because we didn't have a lot of spikes. So we could configure our autoscaler. It was HPA back then. We could configure HPA, so it wasn't very sensitive. Yes, and the amount of operation on Temporal decreased significantly.
Yeah, on the chart, definitely the right side is quite much better than the left side. So definitely an improvement. So did you stop there, or did you do any other improvements?
No, we continued, and even then we have even after this stage we have plans, and we are working on improvements. Because new business logic is constantly added, and when you fix one issue, it almost immediately discover the next one. So it's constant process. Then we merged our activities even more. Currently we have we have two activities in our main metrics calculation workflow, and also we are merging different workflows now, because this is the very basic, the first workflow that we had. But also there are some kind of aggregations workflows. And of course, if you have this workflow finished, you need to trigger the next one, but the duplication problem remains between these two workflows. So to work with duplications better, we want to merge them, and things that were workflows in the past, they will be converted into activities. Of course, total time of workflow duration will increase, but it's okay for us because we are persisting results at the end of activity if needed to show it to the customer.
So far you would recommend to keep your workflows bigger and your activities also bigger and less workflows. Did I get it correct?
Not less, because Temporal can operate with millions, tens of millions of workflows, but you should try to minimize amount of operations that Temporal should do per second. So you can have many workflows, but they shouldn't be processed during a short period of time. It's not a rocket science. It's quite obvious, but I was surprised how bad Temporal works when you have many workflows simultaneously.
Yeah, because I think the first idea would be like, hey, I have this cool solution. Let me serve every, let's say, HTTP request to our system as a workflow in Temporal and do our stuff, that kind of stuff. Yeah, so that's not the use case, I guess. Okay, so this version 3, was it ideal? Was it like perfect solution or no?
It was perfect. It was good in our setup because we were building cluster on top of Postgres. It was a common technology for us, Postgres, like for a lot of people, but it's relational database and not very good. So we decided to move to another database. It's not our application database. It's something that Temporal uses internally. So when you're configuring cluster, you should provide the database for it. You don't need to manage it by yourself, like create schemas or something like that. Just provide an instance. So we decided to move to Cassandra, which is recommended if you have if you need much better processing inside the temporal cluster. And yeah, we as I said, we have DevOps engineers, so they configured Cassandra cluster in-house because Astra, I believe it's Astra DB. It's very, very expensive if you buy it, manage it. And in comparison to Postgres solution that we have, we started paying 3 times less for Cassandra, for 3 nodes of Cassandra. And also it was like 3-4 times faster for us. I tried to collect some metrics here,
That looks great. I mean, if you have total time 45 minutes and then 15, that speaks a lot to it and to its performance. And also the cost increase or decrease in your case, that's also a good factor. So did it go well? Like how Cassandra showed itself in production, in like your user experience working with it, or let's say system experience?
It was our first time with Cassandra, and it couldn't be well and smooth. Like it could be much worse. So when we started with cluster of 3 or 5, I don't remember. Probably 3 nodes. We ran it and started running tests. And everything was good until we run tests like a few times in a row with many workflows. There was some issue with storage inside Cassandra, and for some reason, write latency was very high, and only reload of node helped. So guys started looking for some options to fine tune, and it took us almost 1 month to find the good configuration. Maybe it is related to the fact that it's not good to have a lot of update operations in Cassandra. I don't know, but right now it is working very good. We don't have any issues with it for more than a year.
That sounds cool.
Yeah, we even fine-tuned so we saw that our nodes are too big, so we moved to smaller nodes to save even more money.
That's cool. I'm not sure about the update operation, because Cassandra treats update operation like inserts, so it doesn't really care like whether it's insert or update, just replace the row. But anyway, you mentioned the managed solutions. That's right. There are not a lot of managed solutions for Cassandra. AstraDB was one of them. IBM bought them. They acquired actually DataStax and closed that solution effectively. So there is still a version available, but it's enterprise pricing only. What we've got else? We have AWS key spaces for a compatible protocol with Cassandra, but it's expensive as hell. So managed solution is not an option in your case. That's true. Cassandra, you mentioned what I want to ask, like which version of Cassandra do you use? Because I know there are like that thing like version of 4, version of 5. Some people use one, some people use another.
Yeah, I forgot to mention this. We tried the last one, and there were issues that workflows were just suddenly killed at the middle of processing. So the consistency of workflow history was not guaranteed for some reason. There was a discussion in their Slack channel. Unfortunately, they just sent us a ticket that they will work on it and recommended to downgrade to Cassandra 4. 4.6, I believe, something like that. The last four, Cassandra. And also there was a guy who started selling us his own database at some point of time. He was very, very pushy. He even wrote indirect messages in Temporal Slack. But I'm not sure how this solution is good. And also about databases, there is big discussion in Temporal community about ScyllaDB right now, because it's also Cassandra compatible, but there is no official support from Temporal. I saw some open source projects with ScyllaDB connectors, but as I remember, there are no very cheap tires. So you can either try with something small or pay a lot.
Yeah, that's true. The entry point, I guess, $1,500. So if you pay less for your database, don't even try. But the database is cool. It's nice. It's just not really affordable. So in the end, you said you kind of tackled that problem with Cassandra restarts, right? So right now you do not need to restart the server once in a while, or no?
Yeah, it's correct. So with workflow crashes, downgrade helped. I'm not sure. Maybe they fixed this issue, but it's quite risky because there was no proper steps to reproduce way, and it's not good idea to test if they fixed their bugs on production users. So we could run 2 or 3 million workflows, and only one failed because of this. But for us, it's a lot because we need to keep zero errors. Mm-hmm. Because people are paid money using this data.
Yeah, when you have customers, it's a different story, right? You have some expectation for your company. You mentioned previously one of the use case for Temporal, a durable timer, when a person kind of clocks in and you set up a timer and then send an event. I think it's quite an interesting use case, I've seen different solutions to it. At the time, I think Uber, what they've done, they opened a Postgres transaction when the ride starts and the closed transaction in 40 minutes in an hour when it ends, and it kind of worked till some point, and then it didn't. So that's great that there is such a thing in Temporal, like a timer. Do you have any other use cases maybe for Temporal, any interesting things available there?
As we mentioned before, sagas. So we use Temporal for orchestration of long-running jobs. Let's say usually we need to create big files or big archives of files. So we use this because each file in the package is independent. So we generate, and we don't need big pace here. Customer can wait for this. So we generate each file in separate workflow, in separate activity independently, and then create a zip of this. Also different kind of file of import file processings. And we don't need good pace here, but we need guarantees that data is processed once, only one time, and all the retry logic, everything. What else? Orchestrating regular sagas, and we started using it for cron jobs, because it's kind of a simple problem to solve, but there is a common mistake, as for me, when people start implementing cron jobs using, for example, in TypeScript world, Nest.js cron job decorator. Mm-hmm. And if you have a cluster with many pods, you need to control somehow this runs. If you need to run this only one time, you need to keep only one master and track that this master is leaving, or elect another one to orchestrate this cron job. But with Temporal, this problem is delegated to Temporal. So we just configure schedule a job. You provide the workflow to run, and the schedule. It can be either cron expression or something human readable. And then it is converted to cron expression under the hood. And there are also many policies which is very useful because you can set up that if your long-running cron job haven't finished yet, it will not start new one, or it will start duplicate, or it will terminate your previous one. You shouldn't take care of this, which is good for us because one of use cases. So we want to have real-time data and everything in the system, trigger events to recalculate. But sometimes a person, for example, didn't work. And let's say it's today is working day. He should work, but there were no events. And tomorrow we need to show this day as missed. Yes, but we cannot show future days as missed. So tomorrow we need to look through everything and find days without any events. It's not an easy task because we have like 1 million, more than 1 million employees, for example, and find few without events. It's quite complicated. So we have a cron job which is running during the night, and we are looking for these employees for days without events to mark them as missed days, for example.
Yep, makes sense. Yeah, and at this point also I was thinking about alternative solutions, and the thing comes up on my mind is AWS step functions, which kind of also a workflow definition thing when you can have low code experience. I don't quite like it, but still, they have one useful thing called human in the loop. At some point, like when a human can approve or disapprove like workflow next stages. Does Temporal has something like that, or did you consider implementing something like that?
For our use cases, we don't need this, but I'm not sure about something from scratch, but it's not very easy to implement this for me because you can send signals inside, and that's so. For example, if you need an approval, you set a timer inside the workflow, and it's waiting for signal to be sent inside the workflow, and then it can continue.
Yep.
Maybe they have something like that, but it's easy to implement with signals.
Yep, so sounds reasonable. Thanks.
Sorry, we have a use case for this. Yeah, we have a use case. I forgot. We're using flat file integration to import employees from different systems, something like that. And the problem with flat file API is you upload file into their system, and they are sending batches one by one. They are not ordered. And also you don't know if the batch is the last. So we start processing, and we have another signal listener, and if the batch arrives, then we continue. And this last batch is kind of human in the loop, I don't know. But this signal mechanism is very powerful if you want to have asynchronous logic and you want to continue receiving data. It's not only human. You want to receive data from other sources during your execution.
Yeah, that's cool. I didn't ask you, but I was wondering about one thing. So you had your legacy system, you've built a new system. How did you transfer customers, and how did you migrate from one to another? Was it like a big bang, like new system available, everybody log in into the new system from Monday, or how did it happen? How did you plan for that?
It was very, very complicated in both of technical and product problem, because so when we had this new business logic, there were metrics that were calculated slightly different. Not necessarily because we changed the logic, but we fixed some bugs. And there are always customers who are relying on your bugs. So even fixing all the bugs, it should be very careful. Yes, so we introduced a feature flag, but for us it wasn't just a regular true-false feature flag. For us, it was a day starting from which we are using data from a new service. So we had two services working in parallel. They were both listening to all the events, calculating metrics, but we read events like we switched reading using this feature flag. For example, you have a report for February, and from February 10th, we decide to use data to switch you to new service. So first part of this period we used old data, and second we used new data. And if someone started creating noises, we disabled the flag, used old data, then started communicating with these guys to understand if we have real bug or they relied on old one. And it took some time. And also it was very old logic. So something was not documented. And also these cases helped us to find out edge cases and document them. Because in the new service we started from the clean sheet. Like, okay, we need to implement this and this. Let's do it in such a way. And if we miss something, clients reminded us about it. And also this feature flag helped us to not break their experience. Because once we disabled, they still could use data that they considered as correct. And when this took us around 2 months, something like that, to migrate everyone to use new logic. But then we had the question of old data, because it's not like a true-false feature flag. And we wanted to have only one service responsible for this and only one copy of database. So we started migrating data from the old database to new. It wasn't very easy as well because it's a lot of metrics. Everything is stored in JSON-B formats, which is not very clear sometimes because you can have fields which are not described in your schemas, and it happened multiple times. So we spent another month creating validation and adjusting this data because like when you are migrating data 1 month 1 month old, it's a little bit different that you are migrating data 5 years old, when a lot of business logic changed. And for this we used CDC. We put Debugging listeners for our old database and had everything in Kafka, like entire old table we had in Kafka, and all the data till the day of enabling feature flag for a given company, we transformed using this validation, making sure that it's correct. There was another layer of validation, and that's why we can trust our new algorithm. So we took our old calculated values, then we took old sources, calculate values using new logic, and compared results. So it was not only reformatting, we compared values as well. So that's why we can trust our new system. And we had for different metrics, because we are talking only about the simplest cases here. There is one special metric called hours bank. It's like when you didn't work yesterday, but you worked more tomorrow. We have algorithm that like calculate compensated working minutes and everything. And this hours bank, it's not for 1 month. It can be for a year, for 2 years. and there are a lot of business rules, and this is very important. So when we migrated this metric, this is very important that values that were calculated like 1 year ago are the same that are calculated today using new code. So yeah, this was I dream about data migration of like something raw without post processing. We have currently we have a project to refactor another core part of the system, and hopefully there is no any calculations, just migrating raw data and reformat it.
That'd be cool for sure. Yeah, you took like quite a responsible approach to migrate that. That's cool. And 4 months for such a system, 3-4 months, it's not bad at all, because many systems would migrate half a year to a year for such type of a migration. With all of your experience now, like so far with Temporal, could you kind of briefly say what it's good for, what it's bad for? Any advices in terms of when to use, when not to use?
Yeah, like any other tool, you should use it when you are confident that you need it, or you are very risky and you're looking for some extreme. It's not something regular like Postgres or TypeScript, and sometimes it's very complicated to explain to business that you really need this and you need to spend time to set up this. Like we were happy that our CTO was pushing for this, and we didn't have to explain to business why we need to support this tool and introduce this tool first of all. So this is the first one. Probably you need to think a lot, because if you started using Temporal, it will be, as for me, it will be quite difficult to get rid of this with all this additional logic that Temporal provides you. So why you can need this? As we discussed, it's sagas, much easier. Of course, if you need kind of distributed sagas, it's not the case, because here you still have a single orchestrator for your sagas, and if it's not, once it's not operating, your entire mechanism it's not operating. Another use case, it's durable executions. You shouldn't support like timers that you can implement in your code and take care about failing your servers, about deployment, nothing. It's just Temporal waits until you need, and then run your small piece of code that you need to run after some time. Cron jobs, I like it very much, because you don't need to take care about strategy of how cron jobs are running. That's one. And second, in the UI you have all the log, how your cron jobs were running. If it is like repeatable, you will have this log as well, all the input parameters for cron job and output parameters. You will have all the history. You can configure this retention period and find it if you need. It's not our case, triggers and workers can be in different languages, but at the very beginning we were thinking about implementing synchronous calculation logic using something better than JavaScript. Maybe it will happen in the future, because Node.js is not the best choice for Temporal. Which issues we had during this? So there was a version when we started this, and we were even thinking about moving to something different, because Node.js SDK didn't have parallelism for activities execution. So you have asynchronous language, you can have asynchronous activities on your workers, but worker cannot process more than one activity at the time. And hopefully, when we noticed this logic, there was already a new version like in 1 week, because we asked this question and they were, yeah, it's no issue. We have already fixed it. So wait for 1 week. Now it is much better, but still we have a lot of synchronous operations. So hopefully we can scale it using like different scaling tools. But probably we will try Go at some point of time or something different. Yeah. Because there was an idea at the very beginning, like let's build new business logic with Temporal, with Golang, but we were happy to at least not touch Go at that time, because it could be a hell.
I want to ask this question. Maybe you just answered it, but just in case, what do you wish you knew before starting with Temporal? That Node.js support would be great, or something else?
I would like to knew that like how Temporal is working with activities. With workflows, with huge amount of activities, because we had to learn it by ourselves. Like, of course, our tests showed it at the very beginning, but when we noticed it, we had to rebuild a lot of logic inside. Mm-hmm. And unfortunately, it's not described in the documentation, or at least it wasn't described, because they claim that Temporal can handle millions, tens of millions workflows simultaneously. But they are simultaneously. It's not like simultaneously during one short period of time. It's there can be a lot of workflows active simultaneously, waiting for their time to be processed. Mm-hmm. That's the difference. What else? I would like to know more about testing Temporal stuff better, because they provide some testing tools, but it's still not very easy. With AI, it's much easier, of course. But when we started it without good AI tools, it took a lot of time. So we put it aside for a while. So we didn't test it well. Because their tutorials were not very good here.
Yeah, that makes sense. Okay, so I usually ask my guests to share some developer wisdom with guys, like maybe some tips, tricks, things, or for the team starting with Temporal, or just in general, anything you'd like to share. That's the time.
My advice would be, let's start with cloud solution. Mm-hmm. Without spending your time and resources for in-house cluster. It's not very complicated to set up it right now, but cloud solution is very good to test it. Second, don't be afraid to play with different languages for workers, because with AI tools, it's not a big deal. If you're an engineer, it's not a big deal. Start writing code using new language. If we're not talking about Rust, but they have a very good repository with examples for every SDK. So startup will be quite easy. I played with Go setup. It was very easy. With AI tools, it took like few hours to start building activities.
Yeah, AI changes everything right now.
Yes,
I saw a slide. I don't think you covered it all. The cons of using the Temporal. Can you briefly name those, and which of them are still kind of in play for your setup, for your team?
Yeah, as I mentioned, it's not very performant for short running workflows. Mm-hmm. It's just not a tool for this. Yeah, that was a problem for us. But when we were deeply in this technology, we had to fix it somehow instead of replacing it. Postgres is good for flat load. What does it mean? If you know that your workflow creation and execution is without spikes, Postgres is okay. But in general, it will be much, much more expensive because Temporal inside has a lot of write operations. It's just Cassandra is better for heavy write operations. Yeah, bugs with Cassandra, just don't use last version. It's not written anywhere, and like you see multiple people are saying that Cassandra 5 is working well with this, but like for us it didn't work, and we met one or few people that claimed the same. So it was not very obvious at the very beginning, but it can happen with any tool because these tools are created by people. Yes, also CLI batch operations are very slow. They made some improvements. Also, some CLI operations were not available from the UI. Now they are. And also, even these batch operations, they're using themselves to run this. So you can see internal workflows executions for batch operations in the UI, which is very good. Not very detailed, but still you can track progress of batch operations. Yes, and it's expensive. It may be expensive because still you need to keep database. You need to keep temporal cluster, and there are like 4 or 5 different deployments. And they recommend to have 5 pods per deployment. So it's like 25 pods, plus if you want to have observability with UI, you need to have Elasticsearch. I forgot to mention this at the very beginning because it's not disturbing us at all. It's just working. Yeah, but to have UI working for search tools, you need to have Elasticsearch.
Yeah, I guess as you said, like to try it out, the cloud solution is the best, and then you can decide whether you need it or not.
Yeah.
Andriy, thank you. Thank you for joining today. Thank you for being so candid about both kind of wins and struggles you had. Stories like this, they help architects to properly structure and work with system, plan their system. So with real numbers and honest assessments of what worked, what didn't work, that's very cool to hear. Thank you so much for joining and to telling us all of that. So I was really, really glad to have you here today, and I hope you'll join in some episodes in the future.
Yeah, thank you for the invitation. It was a big pleasure for me.
Thank you so much, and we'll see you next episodes.